Like to get through enough of today's lecture that you could get started on 6.4. This is going to take 2 days to go over. This is uh, graphing in a coordinate system that most of you probably have not seen before. It's called the polar coordinate system, and we're going to be graphing polar equations. It's very interesting. We can get some really cool graphs, but we do need to introduce it and kind of get some basic framework and some building blocks before we do this. It is very similar to some stuff that we've done before, so hopefully you can see the connections. So on the starter question, it says find the magnitude and the direction angle for the vector -4, 3. So that means if we were to sketch what this looks like, -4 would be in this direction, 3 would be in this direction. So we need to know how long this is. That's going to be our modulus. Okay, that'll be the magnitude of that vector. And then I need to know what that angle is from standard position. So let's see, there was that little formula where we could figure out if this was V1 and V2, so that if those are the horizontal and vertical components of the vector, if that made up vector V, then the magnitude of that vector was the square root of, so we'd have -4 squared plus 3 squared, so we end up with the square root of 25. So the magnitude is 5, so there's that part. And then we need the direction angle. There were several ways you could figure out the direction angle. Can somebody give us, what was the one we most typically used? We used a trig function. Okay. So here's what we did. We used tangent inverse of the equivalent of the y, the vertical component, over the horizontal component, which would be the equivalent of the x. So we do tangent of inverse of that, and that gives us an angle. Now, in our case, what angle does that give us? If we type into our calculator, what is it? -36.8. Okay, so it gives us -36.8 degrees. Now, we've got to use our heads here, because we just threw this into our calculator, which you have to use on this problem. It's not going to figure the whole thing out for you. And this isn't a common ratio from a common angle that we typically work with. Okay, so you have to put it into the calculator, but you've got to use your brain. You've got to figure out, hey, you know what? There's no way this could be an angle in standard position, because clearly we can see that this is an obtuse angle. What is this angle right here with respect to this triangle? It has a name. What did we call it? It's the reference angle, okay? So this little angle right here, that little sliver of an angle right there is 36.8 degrees. Now, what I'm really after is this guy right here. I want that angle right there. That's the theta that I want. So how do I figure that out? Okay, remember, we're always adjusting with the x-axis. So we're either going to take 180 and add or subtract something, or 360 and add or subtract something. In this case, if I know this little sliver of an angle is 36.8, I'm going to take 180 degrees, which would be right here, and I'm going to back off exactly that much. So the angle that I'm looking for is 180 minus 36.8. And what is that? 143.2. Okay. So if I take a look at this in sum total, here's what I've got. The magnitude is right here. It's 5. And the direction angle is right there. It's 143.2. Okay. Are there any questions? Okay, well, it turns out that if you have a magnitude and a direction, if you can say how long or how far something is and which direction you point to, there's actually a coordinate system that's perfectly set up for that. It's not the XY plane that we've typically been working with, okay? It's not the imaginary plane or the complex plane that we worked with last week and the week before. Okay, it's something called the polar plane, and here's how it works. We deal with something that are called polar coordinates. We still need those two things in order to locate something. Not an x and a y now, but now we're going to have a radius and an angle. So a radius, that's how far, and an angle, that tells us which direction we turn to. So r is the distance from the pole, or in other words, we could call the pole the origin. Okay, so just a changing of terminologies here. And then theta is the angle measured from the polar axis. Now, the polar axis is the positive side of the x-axis. So this right here is the polar axis. Oops. So polar axis right here. And this little point right here, that would be the pole. Okay, that'd be the center of this whole coordinate system. So we're going to go through and we're going to plot a couple of points. So I'm going to plot the point A. Now, this is the way they're given. I find it a little bit easier to do this differently. So it's given as a radius, or in other words, a distance from the pole. So we're going to go 2 units, and then we're going to turn to an angle of pi fourths. So that means we'd go out to 2 units, and notice how we've got these concentric circles. Here's 1 unit from the pole. Here's 2 units from the pole. So we'd be right here. And then it says, turn to an angle of pi fourths. So if I turn to an angle of pi fourths along that concentric circle, that's where I'd be right there. That is the point A. Everybody good there? Okay. I prefer, and I think it's generally better, if you turn to the angle and then figure out how far you go. I think in the long run, that's much better. So I'm going to locate the same point by turning to pi fourths. So I'm going to be pointing in this direction right here. And then it tells me to go 2 units in that direction. So I'm going to go 1, 2 units. I end up right there either way. Okay. I just think that way of writing things down, or that way of locating points, is better. Turn to the direction and then figure out how far you go. So on this problem right here, gosh, this looks like an XY coordinate. It's not. Turn to an angle of 0, and these are in radians. Turn to an angle of 0 radians. So in other words, point in this direction right here, and then how far do we want to go? 5 units. So we're going to count out 5 concentric circles. So that would be this point right here. Now I'm going to do this one. Here's C. C is going to be turn to an angle of negative 5 pi 6. So negative 5 pi 6. So there's pi 6, pi thirds. Here's pi halves. Here's 2 pi thirds. We're going in the negative direction, of course. So negative 5 pi 6 would be this direction right here. Negative 150 degrees if you want to think of it that way. And how far do I go in that direction? 4 units. So I'm pointing in this direction. I'm going to go out 1, 2, 3, 4 concentric circles. There's the point C. Any questions there? Okay, last one I'm going to do in green. So this says turn to an angle of 5 pi fourths. So there's pi fourths, 2 pi fourths, 3 pi fourths, 4 pi fourths. 5 pi fourths is right here. So we're pointing in this direction right here. And how far does this say we need to go? We need to go negative 2. So even though we're pointing in this direction, pointing in the direction of, let me write it here, 5 pi fourths, this says I actually go in the opposite direction 2 units. That's what the negative radius will indicate. So if I'm pointing over here and I have a negative radius, I back up 1, 2 concentric circles, and I'm right here. So not only is this A, it's also D. There are 2 ways of locating that point. In fact, if you think about it, we could represent it in an infinite number of ways, because I could say, hey, let's do pi fourths, and then let's add 2 pi or 4 pi, any multiple of that. Okay? So there are lots of ways to locate the same point if we're in polar coordinates. Okay, are there any questions? Yeah?
How can a radius be negative? Isn't like a distance? Or is it just different with this axis?
So think of it as 2 separate pieces. This one tells you how far, and the sign tells you that you go in the direction you're pointing. So the negative would just tell you you're going to point in the opposite direction. The opposite of this direction right here is the direction of pi fourths. Okay, good question. Anything else? Okay, so the next thing we want to be able to do is we want to be able to convert from something we're familiar with, okay, like rectangular coordinates, or we'll call them Cartesian coordinates, okay, into polar coordinates and vice versa. So this one says convert from polar to rectangular form. So let's take this point right here, and we want to convert it to rectangular form, or in other words, we want to give it x and y coordinates. Because I could locate this by going over this far and then going up that far. So let's think about this. I am 2 units away from 0, and this angle right here is pi fourths. And I want to know what is the x coordinate and what is the y coordinate for that particular point right there. Does this look familiar? Yeah. It does. How could we go from the radius, the modulus, the hypotenuse on a right triangle, and find this adjacent side, or this x coordinate? We could divide by radical 2, okay? Or in other words, let's use some trig here. We could use a cosine, right? Because that x coordinate is going to be 2 times the cosine of that angle. Or if we wrote it, if we were just solving from scratch, it would be the cosine of pi fourths equals the x-coordinate over the hypotenuse. So if I just times both sides by 2, I end up with 2 times the cosine of pi fourths, which ends up being radical 2. Isn't that what it is? Okay, so radical 2 is the x-coordinate. And then, let's see, if I used this for the x-coordinate, what could I use for the y-coordinate? 2 times the sine of that angle. So that angle is pi fourths. So that also is going to be radical 2. So here's the x-coordinate, here's the y-coordinate. So it would be radical 2, comma, radical 2. We've converted that from a distance from 0 in that particular direction to an x and a y coordinate. So instead of having a radius and an angle, I've now got an x coordinate and a y coordinate. Any questions there? Okay, let's convert from rectangular to polar. So if I've got the point in rectangular form, or in other words, x's and y's, so I'm at -3 and -4, so I'm down here. I want to figure out how far I am from the pole, and I want to figure out what is my direction angle. What is this big angle right here? So in order to do that, I need to know how far. Doesn't this look familiar also? It's kind of like working with a vector, right? We square this and square that, so we're going to end up with the distance from 0, the radius is going to be -3 squared plus -4 squared, so that's going to be the square root of 25. So I've got 5. There is the radius. I've got that piece taken care of. And then I need the angle. So if I wanted this angle right here, I could do tangent inverse of y coordinate over x coordinate. And what does that say? 53.13. So we'll say 53.1 degrees. Is that the answer? It's not, because remember, that gives us this angle right here. That gives us a reference angle. So in order to find the theta we're after, again, we adjust from the negative side of the x-axis, the 180 degrees, and we're going to add 53.1 degrees. So we end up with theta equals 223.1? 233.1 degrees. Okay, so there are the two pieces. Let's put it in polar form. So that's a radius and a direction angle. So this is going to be 5, 233.1. And there it is in polar. There's our radius and there's our angle. Any questions? Hopefully that looks pretty familiar. Okay. We do want to kind of formalize this process and write this down. If I have an x and a y coordinate, and again, this should look kind of familiar. If I've got an x and a y coordinate, I can figure out what the radius is. I just take the x coordinate and square it, take the y coordinate and square it, and that should equal the square of the radius. So that means x squared plus y squared should equal r squared. If I want the, let's see, how could I find the x coordinate, this coordinate right here, based on the radius and the angle? We did a problem like this up above. We had a specific radius and a specific angle. What is it? Okay, it's going to be r cosine theta. Should also look familiar because that's how we were dealing with horizontal components of vectors. And what's it going to be for the y? Okay, it's going to be the same thing, but it's going to be r times the sine of theta. So if I know the radius and I know the angle, I can figure out the x and the y coordinate just using cosine for the x coordinate and sine for the y coordinate. And then we can use tangent of this angle right here. Well, let's see, the tangent of that angle would be the y coordinate over the x coordinate. Now, there's a little asterisk by this. Why is that? Right, if you type that into your calculator, it's going to give you an angle, but not always the angle in the quadrant that you need. Okay, so if we were to do tangent inverse, you'd get theta equals tangent inverse y over x. You always have to make that adjustment with 180 degrees or 360 degrees, okay? Or 0 if you wanted to think of it that way, or the radian equivalent. Okay, any questions? Okay, don't these look familiar? We've used that same idea several times. You're going to want to keep those in mind because that's going to come up again. Okay, so once we know how to graph polar coordinates, graph specific points, we can then graph some pretty interesting shapes and figures and stuff like that. Now, the bottom of this page, not very interesting. I'm going to give you that. So the first one that we're going to graph is r equals 1. All this says is that the radius equals 1. It doesn't give us any information about the angle. So that means we go 1 unit away from the pole and then turn to any angle you want. If you want to turn to pi fourths, turn to pi fourths. If you want to turn to pi halves, turn there. If you want to turn to 5 pi 6. So in other words, you can turn to any angle you want, and there's our shape. So what is this? It's a circle. That's a really simple equation for a circle. Now, if you compare that to the circles that we used to have, x squared plus y squared equals 1 or something like that, that's a very simple equation that represents the exact same circle that this one does that you learned about in 1010 and 1050. Any questions there? What does this one mean? 2. So there's a circle of radius 1 represented by that red equation right there. There's a circle of radius 2 represented by that blue equation right there. What about this one right here? Okay, it means no matter what direction you point, and you can point in any direction you want, you go -3 units in the opposite direction. So if I pointed over here towards 0, which is normally where we start, how far do I need to go? 3 units in which direction? The exact opposite direction. So if I turn to pi fourths, I'd go 3 units in the opposite direction. If I turn to pi halves, I'd go 3 units in the opposite direction. So instead of graphing it like this, I graph it like that. Now, does that make a big difference in the overall shape? No, it's still a circle of radius 3 units centered at the pole. Okay? Any questions? So, these are problems where the only condition the equation gives us is what the radius is, how far you have to be from the pole. Doesn't care which direction you turn to. This is the exact opposite of this. This tells you which direction you turn, and you can go as far as you want in that direction or the exact opposite direction. So, the angle has to be pi fourths. So you have to point in this direction, but you can go as far as you want in this direction and as far as you want in that direction. So, it's a line tilted at 45 degrees. What's this one? Also a line tilted at -pi thirds. So that would be about right here. Okay? So this is theta equals -pi thirds, and this one is theta equals pi fourths. Okay? It would be the equivalent of me saying, hey, will you graph this line for me? This says the y coordinate has to be 3, but we don't care what the x coordinate is. You can go as far as you want in either the positive or the negative x direction. Okay? Any questions? Okay, now if you'll flip the page over. I'm hoping that I can get done with this page, but I doubt it. We'll finish this up on Wednesday, so we'll have to hustle to do that. There's some really interesting graphs that you can graph in polar form. Okay, how many of you have seen polar coordinates before and graphed polar equations? 2.5 people. Very nice. Okay, so we're going to start graphing these the way we typically learn how to graph a new shape. You pick some points, you plug them in, okay, and then you plot those points on the graph. So you'll notice that instead of setting this up as like an XY chart, I set it up as not an R theta chart, I set it up as a theta R chart. It's a lot easier to pick the angle and plug that into the equation and then figure out what the radius is given that particular angle. So we're going to plug in 0 and pi fourths and pi halves, and 3 pi fourths, and pi. We're going to plug those in to begin with, okay? So if I plug in a 0, I get 4 times the cosine of 0. And what is the cosine of 0? 1. So my answer is 4. So you'll notice that what I have here is the way I set it up to you to begin with. I think it's much easier to graph points if you turn to the correct angle and then figure out how far to go. So let's do the next one. This would be 4 times the cosine of pi fourths, which is going to be 4 times radical 2 over 2. So that's going to be 2 radical 2. Now, 2 radical 2 isn't a very friendly number. Off the top of my head, there are probably a couple people in here that can tell me exactly what that is in decimal form. What is it? It's about 2.28. Or sorry, 2.8. About 2.8. Okay? Greg had it back there just for the record. He's at the back of the room. Okay. So 2 radical 2, about 2.8. And then let's do pi halves. If I plug in pi halves, 4 times the cosine of pi halves. Cosine of pi halves is? Cosine of pi halves is 0. Okay, so I'm going to turn to this angle, 0, and I'm going to go 4 units. So that puts me out here. That point right there is 0 for an angle, 4 for a radius. So 4 comma 0 if you were keeping track. Okay, and then right here. Let's see, this is turn to an angle of pi fourths and then go about 2.8. So here's pi fourths, 1, 2, 2.8, about right there. And then if I turn to an angle of pi halves, I don't go anywhere. I'm right at the pole. Now, everybody watch, please. Don't draw this. Do you think this is right? Do you think it makes kind of like a triangular shape? Big corner to it? Okay, here's how we can check this. Let's plug in a point in between here. So let's plug in pi 6. If I plug in pi 6, what is the cosine of pi 6? Radical 3 over 2. So this would be 2 radical 3. 2 radical 3 is about 3.4. So if I turn to this angle right here, I go 3.4. So that's going to be 1, 2, 3.4. That's going to put me about right there. Let's pick one in between here. Let's pick pi thirds. If I pick pi thirds, what is the cosine of pi thirds? Cosine of pi thirds is 1/2. So this is going to be 4 times the cosine of pi thirds. That's going to be 4 times 1/2, so that's 2. So when I point in this direction of pi thirds, I go 1, 2 units. Did it make a nice square type shape? It didn't. Here's what happened. Everybody listening? The radius started out at 4 and slowly got smaller and smaller and smaller the bigger the angle turned. So it looked something like that. So when we were pointing at 0, the radius was 4. And by the time we were pointing up here at pi halves, the radius was now 0. Good there? Okay, I'm going to change colors for these others. And we're going to do, let's see, let's do 2 pi thirds. Let's do 3 pi fourths. And then let's do pi. I think we can figure it out from there. So I'm literally doing this. I'm picking that number, I'm picking that angle, and I'm plugging it in right here. So this is going to be 4 times the cosine of 2 pi thirds. Cosine of 2 pi thirds. Chapter 1, thank you very much. Cosine of 2 pi thirds? Negative 1/2. So this is going to be 4 times negative 1/2, which is negative 2. Okay, let's do the next one. Let's do 3 pi fourths. So 4 times the cosine of 3 pi fourths. Cosine of 3 pi fourths is negative radical 2 over 2. So this is negative 2 radical 2. You with me? And the next one is pi. So I have 4 times the cosine of pi. Cosine of pi is, say negative 1. Very good. It is negative 1, so our answer is negative 4. Okay, now think about this for just a second. when we were plugging in numbers, angles between 0 and pi halves, between 0 and 90, the radius started out at 4 and slowly shrunk down until it was 0. Okay, let's turn to an angle of 2 pi thirds. So I'm pointing in this direction right here. How far am I supposed to go? -2. So I'm supposed to go the exact opposite direction, 2 units. So there's 1, 2. So I'm going to put a point right there. When I turn to an angle of 3 pi fourths, so here's 3 pi fourths. This says the radius should be -2.8, right? So I'm going to go in the opposite direction, 2.8 units. So that's going to put me about right here. And then by the time I get to pi, by the time I'm pointing over here, what's the radius? -4. So I'm going to go in the exact opposite direction, 4 units. And here's what it looks like. It is a circle. Okay? And just for the heck of it, I'm going to label this point right here. This point right here came from this one. This is -2 radical 2, comma, 3 pi fourths. What direction were we supposed to point this in? 3 pi fourths, right? Up here in quadrant 2. Why did we graph it in quadrant 4? Because the radius is negative. That negative tells us that we go in the exact opposite direction, that far right there, the 2.8. Any questions? Anybody wonder what happens if we do this? What if I said, well, we went from 0 to pi. What if we did this? What if we did 5 pi fourths? What if I pointed in this direction right here? Well, let's see. Let's see what happens. This would be 4 times the cosine of 5 pi fourths. And what is the cosine of 5 pi fourths? Negative radical 2 over 2. So I end up with -2 radical 2. So even though I'm pointing in this direction right here, I'm going to go the opposite direction, 2.8 units. So that's going to be back 1, 2.8. That's going to put me right here. David?
Does it have anything to do with the domain of cosine?
Not really in this case. Okay, has more to do with the range. Okay, and I'm going to hopefully draw a visual here in just a second. Okay, are there any questions? So if I kept picking angles, what would happen is I'd go around the circle once between 0 and pi, go around it again between 0 and 2 pi, and again and again and again and again. Okay, all this does is make a circle. Any questions? Okay. Let's see. Let's see if we can do this one really quickly. So let's start by plugging in a 0. And let's not skip anything. Let's do pi 6. Let's do pi fourths, pi thirds, and pi halves. This is really tedious. Before you leave, I'm hoping I can show you a different way to do this. What do you get if you plug in a 0? Sine of 2 times 0. Sine of 0 is 0. So that would be 0. Pi 6. So this is going to be 3 times the sine of, let's see, 2 times pi 6 is pi thirds. What's the sine of pi thirds? This is why you have to know chapter 1 really well. It's a half, isn't it? It's a half. So if I do half times 3, I end up with 3 halves. Yes? No? Did I make a mistake? Sine of 2 times pi 6. So pi thirds, right? Okay. So we want to make sure when we do this arithmetic that you've got this written down correctly. So this is going to be pi thirds. Let's not make any silly mistakes. This would be this angle right here, long side over here. So this is going to be radical 3 over 2. So this is going to be 3 radical 3 over 2, correct? Okay, now, do you know off the top of your head exactly what that is? decimal equivalent so we could actually graph it? No, that's kind of tough. So grab your calculator. Radical 3 over 2 is about 0.85, so we're going to multiply that by 3. So we're going to be about 2.55, 2.6. So we're going to go 2.6. Let's do pi fourths. So this is going to be 3 times the sine of 2 times pi fourths is pi halves, and the sine of pi halves is 1. So this is going to be 3 times 1, so our radius is going to be 3. 3 times the sine of 2 times pi thirds, that would be 2 pi thirds. Should look a little bit familiar. It's just over here. So it ends up being, it's 3 radical 3 over 2, isn't it? Is that right? Yes? Okay. So this is going to be 2.6 and pi halves. So we're finally through the first quadrant. We're going to point at pi halves. This is going to be 3 times the sine of 2 times pi halves. So that's going to be the sine of pi. And what is the sine of pi? 0. Sine of pi is 0. Okay, now, point at 0. Point over here. We're going to go 0 units. Point at pi 6. We're going to go 2.6 units in that direction, so that's going to be about right there. Everybody watch, please. Do you think it went straight there? Nope, it didn't. Okay, so be careful with that. Let's find this one right here. At pi fourths, how far do I go? I go 3 units, so that's going to put me right here. At pi thirds, so pointing at pi thirds, we're going to go 2.6. Do you see some symmetry cropping up here? And at pi halves, so we're going to point in this direction. How far are we going to go? It's going to be 0, okay? So we're going to be right back where we started. So here's what happened. Don't draw this. We did not go here, 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 and here. That's not what happened. Okay, if you think about how the sine function works, it gradually gets bigger and then gets smaller. So the same thing happens here. It starts out at 0, but it gradually gets longer, reaches a maximum radius of 3, and then gets smaller like that. Now, on my crappy graph, I had to make this look a little bit better. It should be symmetric. It should look the same. Kind of like a teardrop. Okay, now watch. Okay, I'm going to graph the point where we plug in 3 pi fourths. I'm going to change colors. 3 pi fourths. If you plug in 3 pi fourths, you get 3 times the sine of 2 times 3 pi fourths. So let's see, that's going to be 6 pi fourths, or that's going to be 3 pi halves, right? What is the sine of 3 pi halves? -1. So this is 3 times -1, which is -3. So even though I'm pointing in this direction, where do I graph the point? Opposite direction right there. Okay? Now, what I'd like you to do is plug in some points in between here. So this would be like 2 pi thirds. And plug in a point afterward. So that's going to be like 5 pi sixths. And find out what the radius is that goes with those. And here's what's going to happen. We're going to end up with a pedal that looks like that. Now, even though we were plugging in angles that were in quadrant 2, can somebody tell me why we're graphing this in quadrant 4? Because the radius is negative, okay? Your job in between now and Wednesday is to figure out what the rest of this looks like. Plug in all the numbers, all the common angles in between 0 and 2 pi. Come up with a shape, figure out why it works the way it does, and then I'm going to show you a quicker way to do that.